I would like to welcome everyone to our product showcase presentation, latest and greatest air sealing and vapor control, presented by 475 High Performance Building Supply, which provides specialized and innovative products for the low energy passive house building sector. I would like to thank 475 for your support of New York Passive House throughout the years. I think you are one of the earliest sponsors, so thanks for your very strong support of our organization. It's my pleasure to welcome Nick Shaw, who is the product consultant for the tri-state area, and John Redzwani, who will monitor the chat and will answer your questions live. Without any further delay, it's my pleasure to introduce you.
Thanks for everyone for joining. I'm going to do an overview of mainly the air sealing materials that 475 offers, and kind of using a townhouse renovation as sort of the case study, and looking at how to apply these systems to a townhouse. Very, very common doing a lot of these kinds of projects in the Brooklyn area. But we will be kind of mainly focusing on doing all the work from the interior, as if it's sort of like a landmark project, so to speak. So I'm with 475. My background is primarily as a contractor and also passive house consultant. So these are some images of projects that I've built. I'm a certified passive house consultant under the US system, and also certified passive house builder. And was mainly doing integrated design build projects where it's the same team designing the project as building the project. So showing here like a tiny house up in Vermont, some single family homes out in Utah, Park City and Salt Lake City, like this community center in East Harlem area. Currently been doing a lot more like fun little woodworking projects, turning spalted maple and living roof cob straw bale project for this little like garden center. But 475, we are e-commerce setup. We service all of US and Canada. So everything that I'll be talking about today is available in anywhere in the United States or Canada. And we also have these really great set of ebooks. They come in DWG files or PDFs and show best practice assemblies for a variety of construction types. So if you don't take anything away from this, the one thing to take away is get our ebooks. They're really great, really helpful precedent. And then feel free to reach out to 475, me or my colleagues, and we're happy to help like hone these in for your specific projects and talk through different assemblies, details, ways to approach these projects. And we offer a wide variety of things. We really do focus on the enclosure. 475 actually gets its name from the Passive House Standard. 4.75 kBTU per square foot per year is the annual heating and cooling demand over from this the international certification. But we offer sheep's wool insulation, wood fiber insulation, variety of windows and skylights. We will be touching on those a little bit. Also HRV systems, through wall HRVs from Lunos, domestic hot water systems from Sandin, which is using carbon dioxide as refrigerant. Check out our website. Our website's awesome. We're above board with everything, pricing, spec sheets, really great resource. So getting more into the presentation, I will be talking about water control, which is different than vapor, which is different than thermal, which is different than air. And I will be using those terms differently. And when I'm looking at assemblies, walls, roofs, foundations, I do have a priority list, and this is the order of importance of water control being number one. It's why we went into caves to begin with, shed the water, kick it away from the building. And then secondly, we're prioritizing air tightness. Air tightness is actually through air is where most of our moisture comes from. It's also where a lot of our energy loss is from. So we really like to prioritize air control. And then we're looking at moisture control. How is the assembly going to dry through diffusion? So we like to have vapor open exteriors and vapor variable interiors. And I'll get more into the building science around that in this presentation. And then lastly, the fourth most important, we're looking at thermal control, the R value. Um, a lot of folks really do get tunnel vision on the R value. And a lot of the materials that have really high R values per inch do tend to be vapor closed, a lot of the foam-based materials. Our assemblies are getting really thick with high performance projects, and we're inherently limiting the amount of energy that moves through that assembly. So we're no longer baking our walls dry. We're no longer oversizing our heating and cooling equipment. We're not putting a jet engine in to bake a leaky assembly dry. So we need to think about how this assembly is going to dry through diffusion. And that's why we really do prioritize vapor control more than thermal control. But it is a holistic approach. There is a constant pull and tug for all these different functions. Starting at the foundation system, looking at historic masonry assemblies where we're doing all the work from the interior. I would say for foundations where, poured concrete is airtight, we're oftentimes using a sub-slab poly membrane between 10 to 15 mils, something nice and robust that won't tear. And we're oftentimes bringing that up what's oftentimes a rubble wall. The rubble stone can act as a capillary break, but sometimes we need to be working in a plastic or a piece of metal as a capillary break. But this is pulled directly from our ebooks. So this is sort of showing what some of the examples of what this could look like. And we're having a fluid applied against the masonry and the Intello on the interior, all kind of coming down to meet the insulation. We do like to prioritize a foam-free approach. Against grade, from a vapor control standpoint, we're fine to use vapor-closed materials. We have the 10 to 15 mil poly, that's vapor closed. But it's nice to use very low embodied carbon materials, and insulation is a big part of our overall carbon budget, as is concrete. So you can be using mineral wool boards below grade nowadays. The wood fiber that 475 offers, you do need to keep it above grade or protected from that bulk moisture. The soil is always damp, so the vapor drive is always coming in. But we can be using mineral wool appropriately sub-slab, which is a great use for it. So showing here, and then that sub-slab poly will come up and get taped to the wall. We're using a tape that is fleece backed for this, so that way we can plaster directly over that fleece tape. 475, we offer a wide variety of tapes for a variety of uses. And we do have tapes for taping that sub-slab poly membrane. We do have tapes for connecting that sub-slab poly membrane to your air barrier above grade, or in this case, a concrete wall, which is probably still below grade at this point. We are oftentimes using gaskets or tapes around any pipes that would interrupt that sub-slab poly. I am seeing a lot of projects use that sub-slab poly install as sort of a testing ground to get their crew on board with taping around pipes for taping seams. It's a good area because you do already have redundancy with your air barrier oftentimes with the poured concrete on top. It is best to do a pre-construction meeting with a true mock-up, oftentimes a window install involved in the mock-up since that's a high risk area. But sometimes it's also nice to get more hands-on practice by just taping sub-slab poly seams and taping around pipes and things. Anything that we can be doing to ensure that we're setting the next person up for success. Oftentimes that's the designer working with a consultant in the design phase and then trying to bring the builder on board with the project and designs as early as possible so they can get familiarized with this high level of detail, particularly around the air sealing details. Then we're bringing the Intello down to meet the concrete or finished floor, or oftentimes the subfloor if there's a wood floor above. We can be taping the subfloor seams with Tescon banded tape. We do have an acrylic-based adhesive that comes out of a caulk tube, Contiga HF. So that's what we're showing off to the left here. So sometimes folks prefer to use more of like a sealant that comes out of a caulk tube just in terms of approachability. A lot of contractors are still learning to work with tape as a building material. But as much as they can start using tape, the better. The Contiga HF is a really strong adhesive, comes in sausages or standard caulk tubes, and it won't crack or harden over time. We don't want to rely on silicone-based caulks because those will harden and crack, and it's not a long-lasting air seal. Oftentimes this becomes an issue for our window installs because we are oftentimes using a caulk sealant on the exterior side for landmark projects with masonry. And someone will need to come by and touch up that caulk down the line. So here's our more typical wall assembly for historic masonry with the exterior being on the left. We have a 3-wythe brick. Sometimes some repointing needs to be done on the exterior. It's really based on existing conditions. And then on the furthest interior side, we are showing the drywall finish and then a service cavity. I'll show more images of a service cavity later on in the presentation, but the general idea is to create a chase so that way your electrical equipment isn't interrupting or piercing your air barrier. Then we have the air barrier being the Intello membrane, which is a vapor variable membrane, actually changes how moisture moves through it based on the relative humidity. Then we're framing in a wall, oftentimes with wood studs if we can, holding those studs an inch or so off of the masonry so that way we can eliminate the thermal bridge by insulating between the stud and the masonry. And then we are treating the masonry so it's at least wind tight, ideally airtight, but at least wind tight. And you do want that treatment to be vapor open or vapor permeable. So 475 offers the Viscon fluid applied material for this, and I'll get more into that later, but also a big fan of lime plaster. Natural fungicide, been around for a long time, doesn't harden and crack like Portland cement. So looking at the Intello, this is an interior air barrier. So it will keep the conditioned air off of that cold surface of the masonry, or if there's a wood framed home, we would see that being the backside of the sheathing. It is vapor variable, and we do need to tape the seams so that way it stays airtight from one membrane to the other. It doesn't matter too much about shiplapping or anything like that. It's not your water control, it is your primary air barrier and vapor control layer. So this is showing how it is vapor variable. It changes how moisture moves through it based on the relative humidity. And our vapor drive in this climate actually changes based on the season. In the summer, it's hot outside, we have air conditioning on the interior. Our natural vapor drive is from the exterior coming in. So we need that assembly to be able to dry inwards. And this membrane responds to that high relative humidity and becomes vapor open at 13.2 perms, which is very vapor open. And then in the winter, it's cold outside, it's warm on the inside. Our natural vapor drive is from the interior going to the exterior. So we want to have this assembly all vapor open outboard of the Intello, so that way this assembly can dry through diffusion towards the exterior, but then we're not moisture loading it with our interior moisture. So that's the way that we keep the absolute moisture content down within these assemblies. Cold air is dry air. It can't hold as much moisture inherently. So we have a lower relative humidity, and this membrane becomes a class 2 vapor retarder, which also meets a lot of our code standards that we need for roof assemblies. I see a lot of roof assemblies relying on spray foam purely because they're trying to hit something that's a class 2 vapor retarder and airtight. Spray foam, the material itself is airtight, but it's installed discontinuous because you have rafters in the way, so you'll have air leaks there. It's also not dimensionally stable, it will shrink over time. So by including the Intello membrane and having it touch this fibrous vapor open insulation, you now have a class 2 vapor retarder with an airtight insulation since it's touching it to meet code standards. So Intello, interior side of your insulation. You can have some of your insulation on the interior side of the Intello, but ideally we want to keep about 30%, 40% of the R value inboard or 60% outboard, or even the further we bring it in to the inside, the better. Does the summer vapor drive load the interior with much higher humidity then? I'll be kind of responding to some of the questions in the chat as I see them come in. Well, it will become vapor permeable, so allow the assembly to dry inwards. Of course, we will have the vapor drive bring it in, and we will be bringing more moisture in during the summer, and this becomes vapor open to allow that assembly to dry inwards. We do like to prioritize a fibrous insulation that can kind of moisture buffer, that can store some of that moisture in the meantime and then allow it to dry through diffusion, particularly in the winter. So that way we're creating a drying reserve and allowing it to dry outwards when it wants to or dry inwards when we want to. With a hot and humid climate with air conditioning interior space, the Intello is just responding to the relative humidity. So here we have this vapor on a graph, vapor permeance on the vertical, relative humidity on the horizontal. But right about 70% relative humidity is where we want to have that throttle point, when we want to go from as vapor retarding as possible to vapor open as possible. Mold grows or accumulates about 80% relative humidity. Anytime you're above 41 degrees Fahrenheit, below 104, at 80% relative humidity, we have mold growth. So in a hot, humid climate, I would say the Intello would still be helpful, but I would say we're probably changing the vapor permeability of your WRB, of your house wrap. Something that might have a little bit of a lower perm rating, still somewhat vapor permeable, not a true poly vapor closed membrane, but something that's able to kind of reduce some of that moisture content coming in. A lot of times we are changing our vapor control locations, particularly on the exterior based on the climate. We want the interior surface to be able to dry inwards as much as possible. So we are not running like a vapor closed paint or we wanted to allow it to dry inwards. We are not putting true plastic behind the drywall like we did in the late 80s, early 90s. We did rot out a lot of homes for that while doing that. So vapor permeability, this is what that vapor curve looks like. There are other membranes out there that are vapor variable, but they have very different looking vapor curves. And we've done different types of Wolfe analysis, hygrothermal analysis, to kind of hone in and show that the Intello's a more ideal vapor curve. We are having an interior air barrier behind our drywall. And for a lot of the wall, that'll be nice and simple to install just on the interior side of the studs, but things will get more complicated whenever we're moving through a floor system or transitioning from our walls to roof in particular. For a lot of townhouse renos in Brooklyn, the floor joists are running from party wall to party wall. And we're mainly air sealing our party walls with a fluid applied and not really insulating, since you can kind of like steal your neighbor's energy. Sometimes we want to insulate for soundproofing, or maybe the occupant next door won't be there and you know, down the line. So then we'd want to insulate. But for a lot of townhouse, we're able to just run that Intello continuous directly on through. So sometimes this could look like running a ledger, where we're placing this membrane and then putting some type of ledger board to then support the floor joist. This is where sequencing becomes really key, making sure that your contractor has this membrane on site and that the framers know to install it at this stage. There's also this idea of wrapping the rim joist, where at the top plate, we put in a floppy bit of membrane. We then set our rim joist and floor joist system and then lap that membrane up. And then down the line, you'll frame a new wall directly on top of that, and you'll have floppy bits hanging above and below that you can tape to down the line. So this is again how sequencing, staging to ensure that they're having this air barrier on site when they need it becomes really key and saves a lot of headache and money down the line. So here we're showing that floppy bit of membrane wrapping that rim joist. There's also a version that's more designed for metal studs, a little bit more robust of a membrane. It can act as a temporary WRB as well. That becomes more key for like CLT projects. Cross-laminated timber is what CLT stands for, or I-joist assemblies. So this membrane's a little bit more robust, longer UV exposure, but same air tightness and vapor control qualities. Again, just showing wrapping that rim joist. This is image on the right's a townhouse reno. They did a skim coat, and then they're putting this membrane to then set their floor joists. They're cutting the joists that were pocketed into the brick, and then that will get a plaster or viscon directly over. Similar idea here, but this is a new poured concrete. Probably much more of a renovation kind of standpoint where they're lopping, just putting this little sliver floppy bit, putting their joist hangers directly through. You do install this membrane with staples. It is okay to fasten through it as long as you're hitting the structure behind it. So you pinch that membrane and it will stay airtight down the line. Here we're showing our fluid applied air barrier, the viscon. The viscon comes in two forms, a version that is sprayable, which is what we're showing here. The sprayable can be brushed on or rolled on as well, and it can bridge gaps up to 1/8 of an inch, which becomes really key for those floor joists and those joist pockets. Oftentimes the masonry is really rough around there. Here they're showing sistering the joist. Oftentimes that's needed to re-level, but we want to hold those sister joists a little bit off of the masonry so we can get that air seal connection, and the sister joist isn't in the way. Here we're showing the version with fibers built in that can bridge up to 3/4 of an inch. So this again becomes really helpful for really rough masonry surfaces. I am still oftentimes seeing some level of repointing done. But if you're using the viscon material, that could you have a little bit more forgiveness of what that repointing looks like because you're able to bridge those gaps a little bit better, as opposed to other available competitors where they're only able to bridge like a 1/32 of an inch, and then you need a really clean, well done repointing job. While with the viscon, you can work with the more variable conditions. More for like wood framed, for renovation, you can use the fluid applied to help transition through that floor system. So the Intello would come up and meet the top plate. It would get taped to that top plate. This image is not showing that tape connection, but there would be a tape connection to the top plate. And then using the viscon to fluid apply the bays to the rim joist and connecting to that top plate, and then the subfloor sheathing above or the bottom plate above. So this is where we weren't able to wrap that rim joist, and instead we're coming in afterwards with the fluid applied viscon. We can just tape around all those beam and joist penetrations. So run the Intello membrane continuous, and then just tape around where it's meeting the Intello there. This is very common. It's fairly easy to do, but just gets a little nitpicky. It's a lot of little taped edges. But I would say oftentimes existing conditions or whether or not you're able to sequence properly would kind of help make the decision of this, if this is needed or if you're able to wrap the rim joist or use a fluid applied. I see a question come in about rigid foam and flat roofs. I'll be talking flat roofs in just a bit. Oh, I guess, sorry, that question's why is it so necessary to have vapor open walls? We want vapor open walls because our vapor drive changes direction based on the season. So we need our assembly to dry in both directions. We don't want to put in something truly vapor closed that wouldn't allow that assembly to dry in that direction. That oftentimes leads to a hard condensing plane where we get kind of a sweating effect or vapor damming and having a lot of moisture build up. Flat roofs where you're oftentimes using a vapor closed roofing finish, an EPDM or TPO, so we have different considerations. Showing, again, just taping around. This is a stone material on this masonry, taping around the joist systems. The sister will become an issue because you could have airflow between those sister joists into the masonry. We do have a little bit more forgiveness with party walls since it's not conditioned air on the other side of the party wall. Here we're showing running that Intello continuous through, and we might have some strapping that will interrupt to help brace that wall. Again, just tape around it. Metal beam. The I-beams have a lot of little flanges to tape around, so it gets a little more nitpicky. And it's metal, so it's more of a thermal bridge, and that's why we're seeing some condensation. Again, just sort of a clean fluid applied install. Really simplifies things. I find for these high performance projects, a lot of the budget is just bringing the building team up to speed. And so as much as we can save on labor, the better. Especially the larger the project, that becomes more and more key. Here we're showing if you do need to insulate that party wall, we're first having the Viscon fluid applied, and we're bringing that up the joists a bit to get that air seal where the joist is pocketed. We are insulating, that could be wood fiber insulation, Gutex coming from 475. We want this to be vapor permeable. And then we have the Intello membrane. We may or may not have a service cavity, and for the Intello, we might need to tape around if we weren't able to wrap with these kind of joist pockets. And now we're moving to maybe like the back facade or the bulkhead, where we're probably more likely using a metal framed in New York City and maybe adjusting things or changing the layout or floor plans to allow more space. A lot of these projects I'm seeing keeping the brick on the front, but maybe changing things in the rear. So this is much more of our metal frame typical construction. Exterior outside on the left, interior finish on the right, interior drywall finish, vapor permeable. We have a service cavity to run our electrical equipment. We can throw insulation in that service cavity if we want. We're running the Intello membrane. This is where the Intello X would become more key, so that way it won't pinch and tear on a metal stud quite as easily. Then we're filling in with a bat or blown in, some type of fibrous insulation. And then we're oftentimes having a dense glass vapor open sheathing layer. And then we're oftentimes having a peel and stick membrane, the Adhero product. The Adhero product is vapor permeable, it's watertight, and it's airtight. It's fully adhered. It's like a giant piece of tape. So that way you don't need to tape any seams, you just overlap the seams. And then we have exterior rigid insulation. This could be the Gutex Multitherm or some type of board insulation that's vapor permeable. And then we have a rain screen vented system and then whatever siding finish. Some projects aren't able to have a rain screen. Maybe their lot lines are an issue or something. If you don't have a rain screen, then the Adhero becomes even more key, because you want to have a WRB that will self-seal around the fasteners, because part of the rain screen is you're creating a drainage plane to shed that bulk water. But without a rain screen, you could have little ledges that the water sits on and then follows the fastener into the assembly. So we want to have a fully adhered membrane that will seal around that fastener. House wrap, also very common to use as a temporary WRB or roofing underlayment for CLT projects. I'm seeing it very commonly for CLT floors or roof systems nowadays. Here we're showing a flange window install with the Adhero. The Adhero membrane would just overlap the header flange, and then we would tape the jambs and sills. We are having a true sill sealed tape that's vapor closed on that sill, since we could have standing water there. But everywhere else we will be vapor permeable. Service cavity, showing some images of that service cavity. Oftentimes it's just horizontal strapping. The thickness of your service cavity is based on the depth of your outlet box. So I have seen projects use the pancake outlet boxes that are more like 7/8 of an inch thick. They're able to use a 1x material. Some prefer something that's a little bit more robust, like a standard 2x, and then they can fill in with a bat as well to get some additional R value. But service cavity showing those outlets. I'm seeing the service cavity used just for electrical, Plumbing, the chases would need to be too thick. That's a really thick surface cavity. We tend to have all of our plumbing on interior walls. Again, surface cavity, Intello coming in to tape directly to the windows, hang your outlets in the surface cavity, taping the seams. Nice big tilt and turn windows. Maybe you can't have a surface cavity or you'll have some pipes running through. We do have gaskets for pipes, but if you weren't able to sequence properly, or if it's an existing pipe that you can't get a gasket around an end, we can do what's called hula skirt taping, where it's a bunch of little feathering pieces of tape moving around that round pipe. And that's how we're getting an air seal all the way around. Here's showing the gaskets, the Roflex Solido gaskets. These are EPDM gaskets with tape built in. So they just come in different diameters where the EPDM sits nice and tug as an air seal and waterproofing around whatever pipe or wire. And then there's tape integrated in, so that way you're taping it to your WRB on the exterior or your primary air barrier on the interior, the Intello membrane. This tape is also fleece backed, so you can plaster directly over it. Here we're showing more of the standard EPDM gasket. I have seen folks just cut this to whatever diameter on site, and then they use a tape connection with the Tescon Vanna tape, same tape that's used to tape the membrane seams. If you're not able to have a surface cavity, we do offer airtight outlet boxes. Devil's in the details for these high performance projects, especially in air sealing. And air sealing around your outlet boxes can become a pain pretty quickly. So you would place your outlet within this airtight box and then tape where the wires penetrate through that box. So that becomes a little nip. This is what it most often looks like on site, just a whole pile of tape. Uncertain if you got a strong enough air seal, apply another layer of tape. It's vapor permeable, so less worried about moisture damming at these locations. But this is oftentimes where we're walking around during the blower door test and feeling with our hands or a smoke stick while the air barrier is still exposed, so that way we can seal any of the penetration. Again, showing that surface cavity. It also helps support dense pack insulation such as cellulose or Havelock wool or Gutex thermofiber, the wood fibers blown in. That way it helps prevent any billowing of the Intello membrane, so that way your sheet rockers can come and install nice and quick. Metal strapping to help pinch that membrane in a different way. You're not running your outlets there, but this is like a double stud metal frame project in Brooklyn. So here we're showing the Intello from the roof coming to meet the party wall that has been air sealed with a fluid applied air barrier. Again, sequencing, making sure that they're running the Intello membrane before they're framing in this wall and roof system here, before they place these top plates. Once they place the top plates, they will be in the way. So we want to make sure we are sequencing properly. Again, this is pulled right from our ebooks. Oftentimes we're trying to really get a very high R value for the roof system. You just want to put as much insulation in your roof as possible, and ideally something vapor open and fibrous. So we have our finished roofing membrane, TPO, EPDM, and then some kind of roof sheathing. Maybe that's existing, maybe that's a new layer of OSB or something. We have our existing rafters, and then sometimes we need to have a little bit of a drop where we're using a piece of plywood or OSB webbing to then attach a new framing member. So that way we can create this cavity even deeper to allow more cellulose, more hygroscopic blown in insulation, and then the Intello membrane on the interior side of this. We have a great blog post called 10 Golden Rules for Unvented Flat Roofs. This is a really good resource. Flat roofs are particularly tricky. It's a vapor closed exterior, so we can only dry towards the interior. So that's where this is a good resource blog post that I'm sure Johnny will throw in the chat. So looking more at these flat roof assemblies. So the assembly can only dry inwards. We have a vapor closed finish membrane up here. And there's times when the assembly wants to dry in, but there's also times when the assembly wants to dry outwards, and it won't be able to. So the Intello allows that assembly to dry inwards when it wants to, but it won't moisture load that assembly when it wants to dry outwards. This is how we're steadily reducing the moisture content within this insulation, within the flat roof, by using this vapor variable membrane. It's also how we meet code, because it's a class 2 vapor retarder. And if your insulation's touching it, now by code, we can call that insulation airtight as well. It is helpful for this membrane to be black, because then it absorbs the solar gain and pushes the vapor drive inwards. A lot of folks want to have solar panels, which would shade that membrane, or they want to use a white membrane to combat the heat island effect. But from a building science standpoint, we want to be pushing that vapor drive inwards as much as possible. If you are topping with rigid insulation, just make sure that you're not trapping any materials between that rigid insulation and the finished membrane. The rigid insulation will be most likely vapor closed. The finished membrane is vapor closed. And we want to try and make sure we're not creating a bathtub within our walls and roof systems, because we are trapping all the moisture in between. That's why it's very key that this insulation is vapor permeable. We do not want to run vapor closed insulation in here. If we do, we are creating a bathtub and encasing our structure within that bathtub. That's how we would rot out our roof system. So we want to be vapor closed on the exterior for this flat roof with the TPEO or EPDM or similar, and then vapor variable Intello membrane on the interior with fibrous vapor open insulation in between. We do offer skylights, glass roof systems coming from Lamelux. What's really nice about these is the curb is pre-installed, and it is an airtight connection and super insulated and thermal bridge free. Triple or quadruple pane with krypton or argon gas to get really low U values, but glazing, especially the install of our windows, doors, and skylights are particularly risky. And it's nice to have this curb already installed to the unit, and then we just lap up our finished membrane to tape directly to the Lamelux. Looking at our window installs. So for a lot of historic masonry projects, we're not really able to touch the exterior. Sometimes we're able to get an exterior tape connection if we have a brick mold. Oftentimes we have that for the header and jambs, but oftentimes we have just the existing stone sill for the sill. You might be able to get a tape connection, or maybe that will just need to be a caulk connection that would need to be touched up. The Intello will come and meet and directly tape to that window frame on all sides of the interior, and insulating with vapor open insulation. We are not using can foam around our windows. Can foam is vapor closed. It will oftentimes create more condensation buildup at that connection. It's also not dimensionally stable. It will shrink over time. So looking at some of the tape options for window taping, for the exterior, we have a vapor closed tape that's used only at the sill, the Extra-Seal Encores. That's oftentimes face taped, or sometimes it is brought all the way to the interior and back dammed. In the interior, we can do a face tape, or we can do a zero reveal tape, a double-sided tape. The zero reveal tape is more appropriate if your drywall finish is dying really close to the frame. It oftentimes means that you need to pre-tape the window though, before you set it in place. Creates a really easy install if you're able to do that. Window corners become particularly hard as well. So it's a little bit of origami where you're doing a little cut, overlapping the tape, and then getting a tape connection. I oftentimes see someone where it's their job just to do the corners, and they're walking around just doing it consistently for every window. Here we're showing pre-taping before setting the window in place. The Tescon Profil tape. Here we're showing setting the windows on sawhorses to pre-tape it. These triple pane windows and doors are incredibly heavy. So sometimes they do need to be craned directly in place or pretty close to it. So this might not be an option, and we sometimes do need a face tape. Here we're showing that double-sided pre-tape stuffing with fibrous insulation. In this case, it's mineral wool around. This is the exterior. That tape just laps up and tapes to the waterproof jamb using the Tescon Vanna for that waterproofing. On the interior, that's showing a plywood buck It'll lap up and tape directly to that plywood buck. Oftentimes we're trying to encase whatever window strapping within the tape, since that could be a thermal bridge concern, but also an air leakage concern. They would need to tape all the seams of the plywood as well, along with the end grain, because you can actually have air movement between the plies of plywood. Now we're going to be passing it over to our daylighting member, Akshaya, to talk about the Bowiso and Optowin windows and doors. And the Bowiso are the wood framed that are more designed for landmark projects where it can be meeting existing conditions. So Akshaya.
Yes, hi. I'm Akshaya and I recently joined 475 as a daylighting product consultant and I rep doors and windows. Some of you, if you're familiar with 475, may already be aware of Bowiso, as Nick mentioned, a company we work with that offers wood windows and doors, and they can also be tailored to landmark projects. I'm here to introduce you to Optowin, who we began to work with more recently. It's an Austrian company that manufactures aluminum clad windows and doors, and tell you a little bit about what they offer. A little bit about the company background. That was founded in 1932. They're pretty well established in Austria, and they'll be celebrating their 90th anniversary in 2 years. And they've also received some recognition with winning the Passivhaus Component Award in 2014 and 2015. They also pride themselves on being a family business. They're on the 4th generation now. So there are 5 frames that Optowin offers that can be divided into 2 categories: the all-round Passivhaus compliant systems and the Passivhaus certified systems. The difference is really in the design as well as the performance. There are 3 all-round systems: the all-round timber, with the U value is 0.127, and they're timber windows, and they just have a little bit of aluminum cladding for protection. And then there are the all-round aluminum clad windows with the U value of 0.132 in imperial. And the frames are pretty similar except for the design. The flush system, which is at the bottom, there's some text that's cut off there, but they perform about the same, and it's really the design that's different. And then you have the Passivhaus certified windows. They have a little bit more stringent U values. That's 0.114, and they're also over insulated along the jambs to offer a smoother thermal transition with the walls. And the Purista system at the bottom also has, it's interesting, they're a frameless system, so the jambs kind of disappear into the walls, so you only have the head and sill. So it's often coupled, it offers a really sleek appearance to the windows, and it's often coupled with the resistor for the doors, because you can't have handles without jambs. And this is a brief case study here. This is a project that uses Optowin windows and doors and it's done by an architect called Co-Adaptive Architecture, located in Brooklyn. And it's won a lot of awards for the design that went into it. Next slide. I think we often associate windows and doors with views. And when it comes to Passivhaus to performance, they're often a prime area for thermal bridging. So you want to make sure that you have triple glazed windows with really robust frames, so that they perform thermally well, and you want to create comfortable spaces. But I think another aspect of it that looking at this project comes to mind is that they can also offer a lot to design. And co-adaptive architecture, they kind of work with a lot of creating interesting lines. And in this project, they used a lot of clean lines, and they also use an interesting color palette, kind of a minimalist and a color palette to set themselves apart. And you can really see here how the clean lines for the windows and doors and the matching palette really complements the design. Some of the more common questions that we get with windows and doors are what would they offer? With Optowin, the standard is spruce, and they also offer fir, larch, oak, and a type of reclaimed wood, which is kind of appears to be aged. And they can be finished in a number of glazed and opaque finishes. And the opaque finishes that are offered are RAL colors, which are also the finishes for the aluminum. And RAL is a color matching system in Europe. It has a pretty extensive catalog. If you see at the bottom right. So you can pretty much match any color. And the advantage with using RAL colors, which is a powder coating, is that they tend to be a lot more durable than liquid applied finishes. So they're resistant to chipping, scratching, fading, and they just last a lot longer. And they're also VOC free. So some of the different configurations that are offered by Optiwin are the standard, which is of course tilt and turn windows, popper windows, casement, simulated double hung, sliding. I think the only exception they have is with awning windows. They can pretty much offer all of the other configurations, and they also do doors. So it's interior doors, lift and slide doors, and tilt and turn doors, which very similar to the windows, and they just come with a threshold, and they come in custom dimensions and shapes. And another variable we like to remind or tell clients to keep in mind is the construction schedule. The lead time on these is about 15 weeks from the approval of shop drawings to delivery. So that's something to keep in mind when it comes to your construction schedules and when you want your window on site. There are also other custom options if you're interested, of course, tempered glass, frosted glass, different security and hardware.
So make sure to do blower door test, inspect, verify, and measure your success. Do a blower door test as early as possible, ideally after the air barrier is installed before the windows and doors, and then again once the windows and doors are installed, and then probably one final one. So I'm commonly seeing about at least 3 blower door tests for passive house projects. But more the better. I encourage contractors to get blower door testing equipment, or I have seen folks just set up a big fan with some type of shroud, whether it's a poly membrane or something, just to pressurize the building envelope to track leaks, even if they're not truly measuring it. That can still be helpful. And again, check out our ebooks, really great resource, come in DWG file or PDF, and go to our website, reach out to us, let us know how we can best support you and your projects and details that you're working on. And very happy to help out as much as we can. This metal framed wall is a 1 hour fire rate assembly. Even with the Gutex Multitherm, we do have testing to show it is 1 hour fire rated. So exterior cladding with a rain screen with the Gutex Multitherm, the Hero membrane, this could also be Mento. And also since the Gutex is tongue and groove on all 4 sides, the Multitherm board can act as your true house wrap for your walls. So you might not even need this Hero or Mento if you're using the Gutex product. Then you have your dense glass sheathing, and then your metal framing, and then you're most likely having mineral wool bats with the Intello X membrane on the interior to act as your primary air barrier. Then your service cavity, you might throw another bat in there as well. So with the Gutex wood fiber, we do have 1 hour fire rated assemblies. We don't quite have 2 hour fire rated assemblies yet, but we are making steps to be offering wood fiber insulation with a higher fire rating to be able to offer 2 hour fire rated all wood fiber insulation. So more of that to come in the future. Another workaround that I have seen is just sandwiching your wood fiber board between 2 layers of dense glass to get whatever desired fire rating. And I have seen that go through code. But happy to answer any other questions, comments, concerns, but thank you everyone. I believe that 1 hour fire rated was tested and not an engineered signed statement. That is included in the Gutex Multitherm spec sheet with the proper wording and testing shown there. If Johnny, if you can throw the Multitherm spec sheet in the chatter for Jay Murdoch,
Sure.
who's asking.
There was one question actually came through, the question about the location of the vapor retarder in your wall system. You know, how much insulation do you recommend on the exterior compared to the interior?
Yeah, so the location of the Centello membrane, further on the interior of the R value, the better. I have seen it where about 60% of the R value is outboard, 40% inboard, and that does still function properly. It's really just kind of adjusting where what point of relative humidity the Intello is responding to, because it is picking up on the average relative humidity on either side of the Intello. So where you place it within that insulation layer will adjust in terms of how it's responding to that relative humidity at that point.
And there's a question regarding exterior membranes. Do you have a membrane which works like the Intello, just in reverse?
We don't. We tend to want to be vapor open in this climate as possible on the exterior. I understand the idea of like, okay, if we have, sorry, I'm moving up the vapor curve for the Intello on the interior like this, if we could somehow like flip that so it's the opposite for the exterior, that makes sense to me. I don't know of any technology that functions that way. So on the exterior, we tend to be vapor open as possible. And also ideally membranes that are monolithic, which is what our membranes are. A lot of the older technology, Tyvek, Typar, those types of house wraps are vapor open, but they're microporous, which means there's little holes in the membrane that expand or contract. It's sort of like how paper works. Those pores can clog or deteriorate over time. Wood tannins actually deteriorate those pores. So they don't tend to be as durable or long lasting, both as an air barrier and as a water resistant barrier. While 475 membranes, they're monolithic and require active vapor transport along a molecular chain. So there's no little pores that can clog or deteriorate. It also means that you can use the same membrane for the roof as for the wall and just lap it directly over, since it will be truly watertight down the line.
To thank Nick and the 475 team for the presentation. We'll make that recording available on our website so you can go back and watch it again. And thanks for the good work you guys do.
Thanks everyone for joining.